Did you know that particles can exist in two places at once? This isn't science fiction, it's quantum superposition, one of the most bizarre phenomena in the universe. Scientists have proven through countless experiments that subatomic particles literally occupy multiple states simultaneously until observed. Imagine flipping a coin that's both heads and tails until you look at it. This quantum weirdness forms the foundation of modern physics and challenges everything we thought we knew about reality. The implications are staggering, from quantum computing to the very nature of existence itself. But how can something be in two places at once? The answer lies in the mysterious world of quantum mechanics, where the rules of our everyday reality simply don't apply. The story begins in the early 20th century, when physicists like Niels Bohr and Werner Heisenberg first stumbled upon these quantum mysteries. They were studying the behavior of electrons and discovered something impossible. These tiny particles didn't follow Newton's laws of motion. Instead, they existed as probability waves, mathematical descriptions of where they might be rather than where they actually were. This led to the famous Schrödinger's cat thought experiment, where a cat in a box could be simultaneously alive and dead until observed. While this was initially just theoretical, modern technology has allowed us to actually demonstrate superposition with particles. Using advanced equipment like electron microscopes and quantum interference devices, scientists can now show that reality at the smallest scales operates completely differently from our macroscopic world. The most famous demonstration of quantum superposition is the double-slit experiment. When particles like electrons are fired one at a time through two slits, they create an interference pattern on the detection screen, exactly like waves would. This means each individual electron is passing through both slits simultaneously and interfering with itself. But here's where it gets even weirder. When scientists place detectors to see which slit the electron goes through, the interference pattern disappears. The mere act of observation collapses the superposition into a single reality. This isn't just theoretical, it's been replicated countless times in laboratories worldwide. The implications are profound. Reality itself may be fundamentally probabilistic rather than deterministic. Our universe at its most basic level operates on possibilities rather than certainties. This quantum weirdness isn't just theoretical curiosity, it's the foundation of revolutionary technology. Quantum computers leverage superposition to perform calculations that would take conventional computers billions of years. While classical computers use bits that are either 0 or 1, quantum computers use qubits that can be 0 and 1 simultaneously. This allows them to explore multiple solutions to problems at the same time. Major tech companies and governments are investing billions in quantum computing research because it could break current encryption methods, revolutionize drug discovery, and solve optimization problems that are currently impossible. The same superposition that seems so strange in theory is becoming the engine of tomorrow's technology. From medicine to materials science, quantum effects are opening doors we never knew existed. But superposition is only half the story. Quantum entanglement takes the weirdness to another level entirely. When particles become entangled, they remain connected regardless of distance. Change one particle, and its partner instantly changes too, even if they're light years apart. Einstein called this spooky action at a distance because it seemingly violates the speed of light limit. Yet experiments have repeatedly confirmed that entanglement is real. This phenomenon could enable quantum teleportation and ultra-secure quantum communication. Scientists are already using entangled photons to create unhackable encryption methods. The implications for space exploration and communication are staggering. Imagine instant communication across interstellar distances or quantum networks that make current internet technology obsolete. The quantum world keeps revealing secrets that challenge our understanding of space, time, and reality itself. Perhaps most astonishingly, quantum effects aren't confined to laboratories, they're happening inside you right now. Scientists have discovered that photosynthesis, the process plants use to convert sunlight into energy, relies on quantum coherence. Chlorophyll molecules use superposition to simultaneously explore multiple energy pathways and choose the most efficient one. This quantum-assisted process makes photosynthesis nearly 100% efficient, far beyond anything human technology can achieve. Even more remarkably, some researchers believe that bird navigation, human smell perception, and possibly even consciousness itself may involve quantum effects. The boundary between the quantum world and our biological world is blurrier than anyone imagined. Nature has been using quantum mechanics for billions of years, while we're just beginning to understand it. This suggests that quantum weirdness isn't an anomaly, it's fundamental to how our universe operates. Quantum superposition may even explain the origin of our universe. According to quantum cosmology, the Big Bang itself could have been a quantum fluctuation, a temporary emergence from nothingness that became permanent due to inflation. The entire universe might exist in a superposition of possible states until observed, which raises the question, who observes the universe? Some theories suggest that consciousness itself completes the quantum measurement of reality. This connects back to the ancient philosophical idea that reality requires an observer. Modern physics is converging with age-old questions about the nature of existence. The vacuum of space isn't empty. It's teeming with virtual particles constantly popping in and out of existence due to quantum fluctuations. This quantum foam might be the fundamental substrate of reality, with everything we perceive as solid matter being just temporary excitations in this underlying quantum field. Within our lifetimes, quantum technology will transform everyday life. Quantum internet will provide perfect security and instant communication. Quantum sensors will give us early earthquake warnings and medical diagnostics beyond imagination. Quantum computers will solve climate change, disease, and energy problems that currently seem insurmountable. But the most exciting prospect is what we haven't even imagined yet. Every major technological revolution, from electricity to computing to the internet, brought unexpected innovations. The quantum revolution will be no different. It might enable teleportation, reverse aging, or even allow us to manipulate reality itself. The boundaries between science fiction and science fact are blurring faster than ever. What seems impossible today might be commonplace tomorrow. The only certainty is that our understanding of reality is incomplete, and quantum mechanics is showing us that the universe is far stranger, more wonderful, and more mysterious than we ever dreamed. The journey of quantum discovery is far from over. Right now, in laboratories around the world, physicists are probing deeper into quantum mysteries. They're testing whether superposition works with larger objects, eventually hoping to put living organisms into quantum states. They're exploring quantum gravity to unite quantum mechanics with general relativity. They're investigating whether time itself might be quantum in nature. Each experiment reveals new layers of complexity and wonder. The most exciting aspect is that we're still at the beginning. Quantum mechanics is approximately 100 years old, but we've only scratched the surface of its implications. Like early explorers mapping new continents, today's quantum scientists are discovering fundamental truths about reality that will reshape human civilization. The questions we're asking now, about consciousness, reality, and the nature of existence, are the most profound in human history, and quantum mechanics is providing the tools to answer them. What does this mean for you personally? Understanding quantum mechanics changes how you see reality. The world isn't as solid and deterministic as it appears. At the most fundamental level, everything is probabilistic, interconnected, and filled with possibilities. This perspective can be liberating. If reality itself exists as multiple possibilities, then your life has more potential than you might think. The choices you make matter because they actualize certain possibilities among infinite alternatives. Quantum thinking encourages flexibility, creativity, and openness to new ideas. It teaches us that observation changes what's observed, that our attention and intention literally shape reality. While we can't consciously control quantum events, yet, understanding these principles can transform how we approach problems, relationships, and personal growth. The quantum worldview is ultimately optimistic. Infinite possibilities exist, and we get to participate in choosing which ones become our reality. The quantum revolution requires global collaboration. No single country or company can unlock these secrets alone. International partnerships are accelerating discoveries at an unprecedented pace. From CERN's particle accelerators to quantum computing collaborations between universities and tech giants, humanity is pooling its intellectual resources to understand reality's deepest mysteries. This cooperative spirit might be the most important lesson of quantum mechanics. Everything is connected. Particles become entangled across vast distances, reminding us that separation is an illusion. The same principle applies to human society. Our challenges require collective solutions. Climate change, pandemics, inequality, these are quantum-scale problems that need quantum-thinking solutions. The same openness to possibility, the same willingness to embrace uncertainty, the same recognition of interconnectedness that defines quantum mechanics must define our approach to global issues. The quantum future isn't just about technology. It's about evolving how we think, collaborate, and exist as a species. We stand at the threshold of a new era, the quantum age. The discoveries we've explored today represent just the beginning of understanding reality's deepest secrets. Quantum superposition shows us that particles can be in multiple places at once, challenging our fundamental concepts of existence. Quantum entanglement reveals instantaneous connections across vast distances, rewriting our understanding of space and time. Quantum technology is poised to transform everything from computing to communication to medicine. But beyond the practical applications, quantum mechanics offers something even more valuable, a new way of seeing reality. It teaches us humility, that our classical intuition is limited. It shows us wonder, that the universe is far stranger and more magnificent than we imagined. And it gives us hope that infinite possibilities exist, waiting to be actualized. The quantum revolution isn't coming, it's already here. Subscribe for more mind-blowing facts, because this is just the first chapter in humanity's greatest adventure, understanding reality itself.